In example 3, we want to find our output voltage, assuming our operational amplifier is behaving ideally. In the circuit below, we have an input terminal with a voltage Vin that's connected to R1. R1 is connected to our inverting terminal, V1, which is also connected to our output terminal, V sub out, by a resistor R sub F, known as our follower resistor. Our non-inverting terminal is connected to ground. For us to begin, we apply our ideal operational amplifier equations. That is, V1 is equal to V2, and since V2 is connected to ground, V1 is equal to V2, which are both equal to 0. And we assume our input currents, I1 and I2, are identically equal to each other and equal to 0. To relate our output voltage to our input voltage, we're going to construct a Kcl equation about our inverting terminal. That is, our Kcl equation would have I in entering, and we'd have I1 and I out exiting. We know I1 is equal to 0, such that I in is therefore equal to I out. If we apply Ohm's law in terms of our node voltages, I in is V in minus V1 per R1, where V1 is equal to ground, and this is equal to I out, which is expressed as V1 minus V out per R sub F. Therefore, our output voltage is equal to the negative of Rf per R1 times our input voltage. We call this particular operational amplifier configuration an inverting operational amplifier. That is, our output voltage is equal to the negative of our input voltage by some factor Rf per R1.